Thank you, Brian. Thank you so much. Mwasma is going to come out a little bit later. You're going to really enjoy what she has to say. I love coming to VS Live events, especially I love coming to VS Live events on the Microsoft campus. Number one, I love this event. It's all about developers, and that's what I want to talk to. I want to talk to developers. Number two, it's on the Microsoft campus, so I can spend time as well talking to my colleagues at Microsoft here in Redmond because I'm from Texas, which brings me to number three. I love it this time of year here because it's about 25 degrees cooler here than it is where I'm from. 100 degrees is going to happen today in Dallas, Fort Worth. Speaking of Texas, before I left here, I was with my wife talking about the event I'm coming to. She generally doesn't want to know all the details I'm talking about, but she's like, what are you going to focus on that keynote? I want to know. I said, AI. She's like, you think everybody's afraid of AI right now that's coming to this event? I go, of course they are. Nobody knows. It's going to affect your job as a developer. It's going to affect you and your company. But I'll tell you what we decided to do in this keynote today is to do this, is to let you get ahead of the game. We want today, in the next 60 minutes, tell you what we know about AI so that you can get forward on this technology. You can decide how to be effective with it and see how it can make you a better developer. We're going to do it from this angle. We're going to start with some fundamentals of AI that we usually teach anybody talking about this from a lens of data. And then Mwasma is going to come into some really pretty interesting details, fast forwarding things that we've done in the past here to what's happening today in AI technology as a developer. Again, with that angle of data and with the angle of SQL, because that's what we know best. And talk to you about how what we're going to present in AI applies to SQL, whether it runs on the ground, on premises, in the cloud with Azure, or now even a Microsoft Fabric. A couple logistics. Everybody wants the deck. I don't blame you. See the site, ak.ms, bobward.ms. I'm an open source presenter. The deck is already up there. We even have full workshop we've done on this topic up there as well if you want to see it. I'll bring that up again at the very end of our presentation in case you don't have a chance to take a picture of that. So hopefully you'll sit back and relax and let us talk about AI technology to you. I know you have questions. We will be at the table topics lunch right after this event. Come meet us, come ask us your questions about anything we're talking about today. When I start a discussion about AI and data, I always put this slide up. And it looks like something you see in a keynote at Ignite, doesn't it? It makes sense because you cannot use AI technology, you cannot build AI applications unless you have data. And here's the interesting part that we know about. And it has nothing to do with AI. Quality of data, security of data, access to data, integration of data. All those things apply to data, anything you're building today. They especially apply to AI because AI can only be as good as the data you're going to feed it for your application. So let's get grounded on a couple of things. Sorry for the pun there. Let's get grounded. When we think about AI, one of the things we do and teach is embeddings and vectors. And Mwasma is going to dive into exactly what that means because it's going to give you a better searching experience. And then we always talk about how to take prompts from things like AI agents, combine them with things like RAG patterns, and use this vector technology inside our databases to be very effective, giving you smarter searches and more intelligent applications. So embedding models you're going to learn are a key thing about using vector search, which I'm going to describe a little bit in a second, like where do you get all these models? But you also have heard of things like language models, chat completion models. And so this entire story is going to involve picking and choosing the right models for your application. There could be different types to do that. And you're going to learn that the power of something called vector searching is going to be a key component as a developer to light up a lot of these features. One thing that I always teach everybody about these prompts and why you even care about this is often prompts you use for searching is not in your data. If you're used to searching for things based on text, for example, that is in your data, one of the beauties of using AI technologies is now you can search for things that is similar to what's in your data, based again on natural language that you understand and know today. What's interesting is if you go back and even look at what we presented last year at this event or what we've done at other VS Live events, this slide looked different because all we were talking about was prompt engineering and large language models. We were talking about RAG patterns to take context of things like databases and documents and augment your search to language models. But what has now become a major pattern for application developers is agent technologies, building agents using LLMs to do things like deep reasoning or store memory or use other tools. And when you see some of the examples Mwasma is going to show you, you'll kind of see practical examples of why using agent technologies is going to become very important as the new AI pattern as a developer for you to become successful. So think in your mind, as you see the rest of this today, prompts, RAG patterns, and now agents as this progression for building AI applications with your data. Well, I don't know about you, but I'm thinking about models out there. I call it the wild, wild west. If you've heard of Hugging Face, maybe you didn't know this. Did you know a model is put on Hugging Face every 10 seconds? 10 seconds. And there's way more than a million. If you go look up the documentation, it says a million. There's way more than that. So we see today the proliferation of the wild west of AI models, which can be a challenge for you. So I think it's important to kind of talk a little bit about our perspective of how we go find these models and how we use them. So number one, we look at things like language model types and sizes. So if you didn't know this or not, there are models called chat completion models. Those are the ones you're used to all the time. If you use ChatGPT, you're using a chat completion model behind the scenes. But along comes things like deep reasoning models you've seen out there, like DeepSeek or Grok, or things in GPT that also provide that, where these models go a little deeper, take a little longer to actually give you information, but with a very good purpose, because you're going to get better answers, more contextual answers, and they're often used in some agent scenarios. But one of the number one things that we call out are embedding models. These models are specifically designed to take your text or even images or audio and take that information, turn them into numbers, into vectors, and allow you to do really intelligent searching with your data. You're going to find picking embedding models can become a very important part of your entire developer experience for doing things like vector searching. But when you build all those together, you're going to combine the use of these chat completion models or deep reasoning models with embedding models to put the entire story together. But as you can see, there are other types of specialized models for image generation, content moderation. And in fact, the other thing that's interesting is the size of models, because you are just used to the words LLM. So one of the things that we see the proliferation happen in the industry is, how do I right size a model for what? Capabilities, resource, and even cost. That, I think, is going to become an interesting challenge for everyone as they move forward, how to find the right one and not have to over-provision things, which we have seen customers do a lot because they're just starting in this technology. So where do you get models today? These are some interesting places to go get them. Many of these are hosting services like Azure AI Foundry or even OpenAI. And of course, Hugging Face is an area where you can download models if you want, many of them open source. NVIDIA is actually invested in this technology. They don't just do GPU technology. They have actually hosting services called the GPU Cloud or Enterprise AI Platform. But you can also download containers that are what we call CUDA-enabled, GPU-enabled, as containers. Right before we got on stage, Mawazma told me, Bob, did you know that OpenAI announced just yesterday that they have 2 new models from their catalog that they've put now in Hugging Face? So finally, the OpenAI teams have begun open. So there's open source models even for them to go put in this Hugging Face model catalog. So if you're thinking to yourself, like, where do I get these things? You need to think to yourself, do I need to access a hosting service or a model that's actually something I can download? Now, as a developer, you need a platform to put all this together. And if you think about applications, you probably recognize some of these icons up here. These are common AI applications that you may be a user of today. But you want to build one yourself. What does your toolkit look like? Well, first of all, you need tools and SDKs. You could be using things like low-code scenarios like Azure AI Studio or Copilot Studio. You could be using things like even PyTorch or Kernel or LangChain as frameworks. But did you know you can use even just REST to go access to models? And you're going to see how we're going to do that with SQL as a technology to do things like embedding generation. And then Mawazma is going to talk about this new, incredibly new protocol called MCP, Model Context Protocol, that are going to light up a new proliferation of agent technologies. So you need SDKs. You got to put this together. But you need models. You could be hosting these models in your code, like in PyTorch, or you could use these hosting services and catalogs to go access them through things like REST. So if you look at this together, I need tools and SDKs, I need models, I may use hosting services to get access to them. Where do I host them? Where do I host my app? Well, the models themselves could be hosted in the cloud, on premises, containers, Kubernetes, you name it. You have the options now to host models separately if you want from your app in many different forms. And REST is one way that we use technologies to kind of help that isolation model. And then you need data. So it could be use something like Azure AI Search Index, which is a very powerful way to go do AI agent applications with data outside your normal data location. It could be things in storage. It could be documents. It could be SQL if you want it to be. But you could use databases like SQL to be what we call a vector store. And Mawazma will go into details about how do you do that with SQL and technology. I've seen customers start to build applications to combine those together, like PDF documents or even files on Azure storage. You're going to find that no longer is there just one place for data to go build these applications, but a proliferation of different types of data sources to put together this so-called agent solution. So that's a look at just the landscape as a platform, as a developer that you're going to be using today to build the apps. What have we learned so far? Like, what are things that we've learned even over the last couple of years? Number one, if you don't have this today, you should create a responsible AI policy. Microsoft, I've got a link in the deck when you look at it, we have one. In fact, we built something called a responsible transparency report. It is excellent. If you're looking for an example of how you could do a policy like this in your organization, I go look at it. I believe there's going to be a proliferation in the industry and our society for more responsible AI. Could even be government regulation, could be compliance from industries. So if you don't have a policy, you should probably go build one. And treat AI models like software. I see people using models like I told, like the Wild West, and they don't understand this is just software, right? It's specialized software, but you probably have policies in your company on how to deal with software you acquire, install. Make sure you're treating models like that. And then this is really important. We've seen customers go out and build AI applications that they do POCs for, and then it just fails immediately. Why? Because they're not spending time designing the right solution. Don't forget to build the right requirements and try to build the right solution, and just don't go off and say, I just need a chat bot for some reason without knowing why. And put the right guardrails in place for policies and securities to go access this. That could be part of your responsible AI policy. And then most importantly, choose the right model for the right solution. Go start understanding those types of models, their capabilities. For example, I may go choose a model for embeddings that don't support multiple languages, yet part of my requirements is to support multiple languages. So there's great information when you look at these models to decide, do they meet my capabilities? In fact, if you look at this screen here, we have an FAQ ourselves we built for choosing the right embedding model for vector searching with SQL. And then number one, review your data quality and security. Again, as I said in the beginning, we've seen customers go off, start building an application and say, it's terrible. The results are wrong. We find out the data quality is no good. And they're like, well, this thing isn't secure. Like, well, do you have security controls already on your data? So don't forget those fundamental principles. We have, over the last couple of years, seen customers not look at these things and fail as they go down the journey to build an AI app. So that might be fun before I turn it over to Mwazma to show you something I just built, something pretty new to show you what's possible from a low code scenario. I am using the famous AdventureWorks example, and I'd like to go in and use Copilot Studio to go build like an AI agent. So I deployed a hyperscale Azure SQL database pretty easily based on AdventureWorks. And then I'm going to go into Copilot Studio and build an agent without writing any code. I'm going to call it the marketing assistant agent for my marketing team internally in our organization. And you can see here, I've enabled GPT and given instructions on how to behave. This is typical to build any kind of AI app. But again, I'm not writing code to do it. But I need knowledge, I need context to give it. So what I'm going to do is I'm going to go add an Azure SQL database, but I'm going to disable web searching. So I'm not going to let this model go search the web for answers. I want it to be private and secure just for my data in my database. So I'm going to go connect to an Azure SQL database. I'm going to give it a server name, database name, inside Copilot Studio because it can add it as a knowledge. And I'm just going to go add the various tables that actually belong and go with this example. Because again, my goal is to be a marketing assistant or build that kind of agent to help the marketing team. So let me pick all these different type of tables because I want that agent to use all of this schema and all the data in it as knowledge for me. So when I've got this in place with my knowledge added, I can go over here and I can start doing some testing. Like, hey, why don't you analyze sales data, give me specific recommendations for a marketing campaign, and be very specific. Give me like revenue numbers and sales numbers to back this up. So in Copilot Studio, it kind of shows you the progression of how it's searching for data and coming back and giving you a final solution. This is pretty cool. Not only does it give me general recommendations about how I might do a marketing campaign, could be promotions, it could be cross-selling, it could be social media campaigns, but it actually looked at my data and says, hey, based on your data, I have specific recommendations based on your sales and revenue. Like, go do a campaign idea for that product because we believe based on the sales, it's going to be the best success for you. So pretty cool example. We're not any code of building an agent based specifically privately in my data. I'm going to use SQL database and Fabric for another one. I'm going to build like a, I don't know, something to help me do shopping, like for a customer. Did you know you can build a SQL database in Fabric itself? I'll take the same AdventureWorks database, deploy it in Fabric, use that in Copilot Studio, get my connection string over here that I have inside my Fabric interface, go take that information, go back over here, build a different agent. This time, it's a shopping agent. Very kind of typical scenario. Use the same construct, though, a different set of instructions, add the same knowledge source, and be able to come over now and have it behave differently to help me shop for things. And I want some of that power of smarter searching. So I'm going to go in and give it a very generic thing. What's the most popular mountain bikes? Like, show me the most popular. So instead of having to look at ratings on a website, it's going to quickly come up and show me, based on actual numbers of what's going on in the organization, what is the most popular bikes. So I can go in and say that it's going to look at my knowledge and say, hey, just based on the number of orders, this is the most popular ones. But I want a multi-turn conversation with this thing. Can I just say, I'd like to know more about this one here, this particular one, like the Mountain 500 Silver 52. So I can just go in and say, hey, let me go in. Notice it prompted me. Is there anything special you want to go look at? No problem. I'll put it in. I'm most interested in this one. So now it can come back and give me details of what's going on with that particular bike. Quick, easy way to get started using Copilot Studio with your data. One can be based on private about your data. One can be more of an external shopping type agent. Well, I think it's time to get a little more deeper here than what we've done. And you need to know when Wasma is going to talk to you about what's happening with vectors and agents and RAG, that it all applies ground to cloud to Fabric. When you're using SQL technology, we want to make sure that any of the things we're doing with the AI can work. You're deploying the new SQL Server 2025 on premises. You're doing an Azure SQL, or you're doing SQL database in Fabric. So right now, I'd like to bring on the person that runs our AI strategy for SQL Server and program management, Wasma Zaid. Wasma?
Thank you, Bob. How many of you are developers? You're at the right conference in the right event. So as Bob mentioned, that I'm going to go into some of the details as he showed some of our integrations with Copilot Studio, an AI platform, and then the app stack. I'm going to go deep into kind of the engine and what we have supported in the SQL Server engine that goes from ground to cloud to Fabric. The first and foremost is the base of is the vectors and vectors in Azure SQL. It also works in Fabric. It also works in SQL Server. Vector data type is the newest one. It's in public preview for Azure SQL. It's actually in GA. Correct me, Tavada. Yeah, it's GA now. The data type is in GA. You can definitely now go in using T-SQL, define a vector data type, something like that. A typical vector when you're using with OpenAI has a lot more dimensions. So for example, a typical embedding model may be 1536 dimensions. Here I'm just showing you just 3 dimensions for that. We have new functions like vector distance, which can help you find similarity between 2 vectors using Euclidean, dot product, or cosine, some of the top algorithms that we have. And some example like that by showing a distance between these 2 vectors, this is a numeric floating numbers. Now, why this is important, why do you need to know about this, is to actually do better, smarter searching with your data in SQL. Now, how do you do that? There are 2 types of things that you can actually do semantic searching on. And semantic is really not a text-based, like it's not a like operator. Doesn't have to be exactly the word in your data. For example, if you're looking for something like a bike for outdoor activities, the word bike and outdoor activities doesn't need to be in the product description. The semantic meaning of outdoor activities and bike combined together using the vector searching algorithms like the nearest neighbor one or an approximate nearest neighbor one is something that you can now do using these native vector types and the semantic searching algorithms that we have. Today, we support through vector distance. I mentioned already cosine, dot product, and Euclidean. We have already a DiskKNN index. DiskKNN is a Microsoft Research open source library that Bing uses for the large scale of search that you all can go on Bing and search on. We are building that as part of the core SQL Server engine. It's already available in the public review for SQL Server. It's also coming soon to Azure SQL. Now, you can actually start doing this similarity searching with vector distance. Again, you have the choice to do kind of the nearest neighbor one. If any one of your machine learning background, you know that you have been doing this for a long time. That is very exhaustive. Disk-NN provides an approximate way of doing the same thing with the top end clause, and then you can do that. How do you do that? This is an example of T-SQL code that you can do that. A lot of our examples are available in the Azure samples. My team spends a lot of time putting our samples out there. This is a very simple example of how do you actually take an embeddings, get an embedding, go to an OpenAI model, embedding model that Bob talked about, convert that text into floating point representation of that text, which what we call as embedding. Once you have vectorized that data or converted that to embedding, now you can start using vector distance function to find any new text that comes in your search. That is what we call smarter semantic searching on your data using vectors. Here you can see this is the foundation series by Isaac Asimov. You can search for that term. That term gets converted into floating point numbers called embeddings. And then you can do a vector distance. Here we're doing it cosine distance and finding for any Wikipedia text that is similar. And you can then apply all the filters on top of that. For example, a book written in XYZ this year, that year, all that filters can be applied. So this is what we call semantic similarity search using vectors. And this we have been working on for a very long time, for about 18 months to 2 years now. Now, what about hybrid search and this thing called RRF, right? So good news is that SQL Server was actually supporting BM25 algorithm since a decade. This is our full text search. All the other specialized vector databases are now implementing this to actually what we call a hybrid search. For example, in your search application or anything that you are actually searching on your data, you want a combination of both actual text-based text and semantic search meaning of that data. Now, what you can do is this thing called RRF, reciprocal rank fusion, where you can choose to decide when to go with full text versus semantic search and give a weight of that. The example and samples, again, are available for you to try it out. We already support BM25 as the full text algorithm, and we are actually working on a further simplified version of semantic searching on your data with SQL Server, again, ground to cloud to Fabric. Now, what is this thing about AI agents? Everybody in this year, 2025, they're calling the year of agents. Bob showed you a low-code, no-code example of doing that, building an agent on your data. I want to give you a real example. Again, I've taken the name out of the customer. It's a real customer that is building a similar application. We have taken the name out and I kind of anonymized the application name. Why we're talking about agents, and I just introduced RAG pattern and similarity search and already talking about the limitations of that. Now, when all of you, if you've ever worked on SQL database or any database in general, you know that it is precise. When you're looking for products in this category sold in the last 3 years, that's an exact search. With vector search, it's an approximate search, which is about the semantic meaning of that. Now, when you go the RAG pattern route, you can do a lot of similarity searching and approximate finding of the text related to that. But our customers are really looking for a combination of those two things. For example, they're looking for, show me all the products in the category video games updated in the last 3 days, which are about mountain bike XYZ. Now, this last part is about vector search, but everything else is a simple SQL statement. Now, how do LLMs can do that? LLMs are not great doing this exact search. That's where you need some kind of orchestration engine that understands the natural language to query or natural language to SQL operations and combine that with the vector search capabilities and giving you the answers. So this is the definition that Kevin Scott actually gave in the Microsoft Build keynote this year. And I really like that. It's very simple. I know there's a lot of debate in the industry. What is an agent? What is an autonomous agent? What is an AI agent? All of that. And this is the definition I really resonated with me. It's about agent is a thing that a human can delegate a task to. And over the time of the last 6 months to 1 year, these tasks are getting more and more complex. For example, in order for you to build an agent today on your data, these are the 3 building blocks that are needed. You need generation, so you need some kind of LLM, SLM, a model, a chat completion, embedding, things like that. You need retrieval, which is on your data, taking your data from your SharePoint, from your SQL Server, from Azure SQL, maybe other databases, spreadsheets. You need a vector store, things like that. And lastly, you need some kind of action. Again, this is a big debate. How much of the control you want to have on these agents? Do you need human in the loop? Do you want them to be completely autonomous? In my understanding, if you want to build an AI agent, it needs to understand where is your retrieval coming from. It needs to have memory. It needs to have some kind of coordination. And it needs to understand what is the goal or task that the agent is supposed to do. Again, going back to what Bob mentioned, what we have learned, the more prescriptive, the more time you spend on designing this, the better the outcomes are. And don't forget the guardrails. Don't give this agent the access to completely delete databases or things like that. Give it the access of the assumption. And even some customers are going up to up to this point where they revoke access after action is taken as well. So you have all those choices. Now, what we have seen personally, and I've been on this journey for about 2 years now with my team. When we started this journey, it was all about prompting. You give a prompt in LLM, you get an answer. The last 1 year or so, it switched toward a single agent where we started to see RAG pattern, chat with your data scenario with additional context with your data. And now, most of these companies, most of these organizations, folks like yourself are thinking about multi-agentic systems. This is a common question I get. How many agents should I do when I'm building a chatbot? Should it be 1, 5, 3? I ask back, what are you trying to solve? What is your use case? What are you trying to solve through this application? And then think about the use case, design, all the guardrails, access, and go from there. This is a simple example of an agent. For example, if I have an agent which can do a booking for me, think about a company like Expedia or some online booking company, where you can go and directly chat and say, help me book a trip to New York for a client meeting. I need to fly out next Monday and return on Friday. In order to build an agent that can understand this natural language and really do the action on your behalf, it definitely needs these 3 things. It needs the generation, which is the model part. So you can go to Azure OpenAI, you can go to AI Foundry, you can go to a Hugging Face-based model that you have downloaded or maybe hosting on-prem. That is definitely needed for the generation part of it or completion part of it. You need access to knowledge sources, the systems which have the itineraries, the CRM, the customer data, all those things kind of connected to it to actually make booking on your behalf. And finally, the actual booking needs to happen. So Azure Function, if you're doing Azure, is the best way of doing that. You can actually use logic apps. You can go low code, no code. There are different options out there. This is a very simplistic approach of what you can do to build an agent. So definitely these 3 are the building blocks. Now let's take that real example. In this example, this insurance company called Contoso Insurance is building a chatbot for their internal employees. It's a business app for their representatives. We used to call this agents, but not to confuse you all with AI agents and the Contoso Insurance agents, I'm going to call them Contoso representatives. Now, I am a Contoso representative. Here in US, all of you are insured for your car, for your anything valuable, maybe other types of insurances as well. Now, as an insurance agent or insurance representative, there's a customer named John Doe that reached out to me to learn more about something. Now, in order for me to better serve that customer, I need to chat with this system or this app to learn more about that customer. That's the scenario. And this company actually built a multi-agentic system, a very simple one, but very effective, that can take natural language questions, give you all the answers about the customer that the representative is asking about, and solve that. How do I do that? Let's take the example. So I am the representative. I go to this app, Contoso Insurance. I ask about, I'm meeting with John Doe later today. What can you tell me about it? Now, it's a very abstract, high-level question. Now, if you and I have been asked this question, we all own a SQL server, or we own a Azure SQL or some database, and we know this, we're going to go and search for that customer first name, John, last name Doe, give the answer back. That's exactly what it needs. So it needs some system that can give information about customers. And once it has that customer information, it has to go find about the information about their policies, insurance, last conversations, anything like that. So the first part, we all know this data is in SQL. So in this case, the customer has this database has their policies, communication history, claims, all of this. And the way we are going to tell this orchestration or this agent, we're using semantic kernel, which is an open source library. Here in this conference, there are other talks about that as well. So definitely learn more. you can definitely build the same solution using LangGraph and LangChain. Semantic kernel is a similar library, open source, completely to build that kind of AI agent orchestration on it. So in this case, we have to give it metadata about your data. So this is the instruction you will give to the orchestrator agent that I have these tables, and this is what you need to use when you're actually querying about customers or other information. Now, once I have the customer information, what do I need to do? I need to know about their policies, their communication history. Maybe I need to do similarity search on their previous history or talking with kind of our company in the past. That's where it needs to understand different other aspects of your database and other systems. So again, this orchestration will be thinking about what are my tools? What do I have access to? So again, simplified solution here, 3 agents. One of them is a customer agent, which can tell you all about customer. The second one is the claims. And the third one is about a web search, which means anything which is not fulfilled from the first two, it will go do a web search for me, give you a high level answer in that case. And this is an example of the communication history table where all of the past communications, mails, calls are in text format. It's the ideal place to actually vectorize this data, store it as an embedding, and then do similarity searching when I'm looking for what this customer has been up to in the last 3 months, 6 months, 1 year, and so on and so forth. Now, to simplify the solution, before I show you the demo, the same question goes to the orchestration agent. That agent kind of goes to the CRM, goes to SQL, converts the natural language into SQL, returns the data back to me, gives me a customer ID. Once I think that it's the right customer ID, you can go to the claims agent where I can find information about John Doe specifically and any more information about that. And finally, if something is not answered through those two, I'll show you an example where I'm asking a very generic question where it will go to web and do additional search. Everybody still with me? Great. So now let's see this in action. This is the recorded demo for the application. It's done in the debug mode, so you really can see behind the scenes what is happening. The intention of this is to look like an insurance app. So it's not very fancy looking front end. It's actually showing you the debug mode for that. So once I start this, I will go in and actually ask the first question. And I'm going to say, I'm meeting John Doe. What can you tell me about that? So I am the representative, insurance representative. What can you tell me about that? Now you will see right away that it's going to, I know the font is not great, so you just follow along. I will try to point you to the right things that I'm trying to explain here as well. The first thing it's going to do is to run that SQL command. It understood my context. It did the select star from the customer table, going to the first agent, where first name equals to John and last name equals to Doe. You see that it actually summarizes it in English and says that I found several individuals named John Doe in our records. Here is the brief summary of each. It will give me the 3 John Does that are in the system. One of them is in Bellevue, one of them is in Redmond, and I think the third one is in Seattle or something like that. So these are the 3 John Does, Bellevue, Redmond, and Kirkland, actually. So I get the summary of the 3 John Does. Now, I as an agent or I as a representative, I know this one is actually in Redmond. So I'm going to say he's in Redmond. So now it's going to go very specific to go find that John Doe that lives in Redmond. You can again see it will go back, run that query for me, and now go to the next agent to find more information about that customer ID 920411, which is the John Doe that lives in Redmond. Then it's summarizing in plain English. The John Doe that lives in Redmond has all these 7 policies, the summary of the policies, and all the past different occurrences that they've had with us. Now, you and I, if you have to do this, it will take us at least 20, 30 minutes if we know our data well. Now, within few seconds, this chat application is able to give me up-to-date information about John Doe. So far, all it has done is natural language to SQL. It has not done any vector search yet. There's no similarity searching yet. Now, I'm going to ask specific question. Is there anything specific about this customer, about price increase? Because usually customers reach out when something is changing. Now, that word price increase doesn't need to be in their communication history. That's where the semantic searching or the vector searching is very, very important. So here you can see it will go to the table and go into actually doing the vector searching for me. And again, going to an OpenAI model, summarizing all the records of the communication history which have anything related to price increase. Now, the word price increase, again, doesn't have to be in the exact communication history. This is really, really powerful. Within few seconds, I could get the summary of John Doe, everything about the recent communications, the couple of times that they were not happy when we had made the changes for them, increase in the price or anything like that. Again, built with 3 sub-agents, 1 orchestrator engine using semantic kernel, C#, and a simple example. Now, this is really the great thing about semantic searching. So far I showed you natural language to SQL and semantic searching. Now, what about that web search? Anything which is really going beyond the exact. Here you can see in this screenshot part of it, I can actually go and ask specific questions about the policies, which are exact questions. They're not semantic search questions. I can ask about policy number 1. I can ask about what they've been doing. So again, it can switch between your exact search to a semantic search and probably combine them together in one chat app. If you're building an application that you definitely need to think about both scenarios because you don't know what your end user are going to ask about. Now, what I really liked about this demo, which was built by David Emory and my team, is really interesting thing happened and he was really wowed by it. Is something about asking a generic question. Is there anything, could you help me to keep John happy and keep them in the system? So now it's actually doing a history of everybody else, looking at John's pattern and see what we have been able to do with other customers where we are able to retain them through these 6 or 5 things. For example, loyalty discounts, customized solutions, so on and so forth. This is a generic thing. Now it was able to do both combinations. Now you can actually go further and say, is there anything specific about John Doe that I can offer which is true to his history? And you'll see that it will suggest to use the new safety score program because John is a great driver. And knowing his driving record, this new safety score program that our company has been offering, it will be the right fit for it. So again, doing all of this research, building this on your SQL database with the knowledge of your data, if you really know, understand, it might take you 1 hour, maybe 90 minutes. For me, definitely it will take 45-ish minutes to go get to this information. Now here, within 3 seconds, 3 to 5 minutes, not seconds, I'm able to get up to date about John Doe. I can go talk to have a meaningful confirmation. So this again shows you the power of building a real agentic application on your SQL data using the new vector data type and the AI frameworks that we have now got really great integration with. We have integration with EF Core, we have integration with Logic Apps, we have integration with semantic kernels, we have integration with LangChain, and we're working on other frameworks as well. If you have feedback, please share that with us as well. All the example and demo that I showed you is available here. This is the high-level architecture of that using semantic kernel, C#, and Azure Functions. You can actually download this example, change it, switch it with your database, and it should be up and going. Now, in terms of some of the newer things, so what is this thing called model context protocol? How many of you know about MCP? Most of you, yeah. When I was coming in here, I saw one of the booths there has a big kind of poster out there about this as well. So model controls, the MCP is basically kind of a USB-C of the AI era. How do you talk to LLMs in a standardized way? Now, there's a lot of buzz about it. There's a lot of changes happening in the protocol itself every week. If you keep up with this, you can go to this model context protocol.io. It was introduced by Anthropic as they were seeing people building applications, finding so many different ways. Should it be direct access? Should it be through server, client, all these other things. Now, thinking of MCP, it's a standardized way of connecting to that. Many of since it has been launched, VS Code supports that. Many of our databases now support that as well. And we actually went ahead and created a standalone MCP server for SQL Server, which works across ground to cloud to Fabric. So the same server works across for Azure SQL and SQL Database in Fabric. Today, you can download this here and you can self-host it. I will show you a quick demo for this. Today, it supports most of the standard operations such as listing, describing, creating table, and other examples. We are working on a separate approach with Data API Builder, which I'll show you the last demo here quickly of how you can actually do the natural language to kind of query stuff using MCP as well. But if you want to just use a LLM-based way of connecting to your SQL Server, this is the way to go. A great example and sample is available at this repository. There's a blog written by Arun and my team. All you need is to download this MCP server. He is using the agent mode in VS Code. And what it does is here is an example of an event administrator, somebody who's, let's say, organizing this conference. And they want to have this database of all the speakers, talks, abstract, and all of that. And I want to go ahead here in the agent mode, directly go in and add and provide information about different rooms, speakers, and all of that. Again, a natural language way of accessing your database directly in the agent mode in VS Code. You can definitely use this in your applications. I can go and further add more information about, like, add a new speaker to it, add a new room to it, anything that you want to do operational in databases, now you can do through natural language directly using MCP. So this kind of completes the journey of what we started with: vector searching, similarity searching, then to agent support with AI frameworks, and now a standardized way of doing that through MCP. You can see that it can create tables, it can give me samples, it can do this example goes on and on about all of that. Now, I wanted to bring this all together and summarize in a real example, again, going back to insurance. And this is the scenario where, again, using insurance, because that's an enterprise-grade insurance application, which requires the security, and privacy of your data, and bringing all of the new developer and AI features together. So this example is actually a hyperscale-based Contoso Insurance line of business app. So let me run this video and show you how this company was able to build and modernize their application. Starting with a hyperscale SKU that we have in Azure, they're able to create an updated version of their app. This is a line of business app. Here you can see I can click on every single customer. It gives me all the information, all the insurances they have access to. This is a web app. Now, the first thing that I will do is modernize it by adding Data API Builder. Data API Builder is an open source REST and GraphQL API platform for you. With a simple config file, you can provide REST or GraphQL. You can choose both, or you can have just one. It can give you full access or full control of what permissions this API layer should have. Here, in this case, we're saying it should have access to these items only, and that will be the API layer for your data. Few seconds, literally dab config, add, and dab start. You're up and running. Here in the console, when I go through these different tabs, you'll see the log will create the query for me. And this is SQL optimized query. The way we write this data API builder is really, really optimized for what's best for SQL. Now, the next addition to this app is adding the new JSON type. We now support a native JSON type. Here, what we're going to get is the CRM data adding to the same SQL database through JSON. We have the new data type and a bunch of JSON functions like JSON path, exist, JSON value, and a performant JSON index. Yes, we have a new JSON index that you can use on your JSON data in Azure SQL today supported. We also have regular expression. This has been a long time ask what we have been asked for, and it can also be added in your query. Now, everybody is doing AI. I was told by my company to actually add AI to my app. So I'm going to go ahead and actually create a vector type on the same table. In this case, using the stored procedure called SP invoke REST endpoint. Bob talked about this REST call. That's where we can calling from natively T-SQL call and REST-based endpoint, which can be OpenAI, it could be Azure OpenAI, it could be third party from NVIDIA as well. And then use the new vector distance functions to find similar things that I'm going to be searching in this app. So far, what I did is I moved my app to hyperscale. I added the new JSON type and regular expressions. I added Data API Builder, and I added the RAG functionality to the same app. Now, what about this MCP? So MCP is, as I said, a standard way of doing this. We are going to support through Data API Builder, standard way of talking or chatting with your data. So now in this case, again, showing you in the C# code, I have this example of the standalone MCP server for SQL Server that will be enabled through DAP. I'm going to actually provide access to the claims, updates, and some listing functionality. Now, in this app, just clicking on this chat, I can start asking questions about listing of all of the customers that have this. Simple as that. that natural language gets converted through the MCP server using DAB and listing me all the 4 customers that I have. I can actually update, because in this case, I have access to update. Then there's an error in the name John, and I'm going to actually update it, name John to Marcus in this example. Now, they have a new customer named Samantha who has new insurance on the wedding ring, and she got married, so she wants to update her last name as well. And with a few chat here back and forth, using the MCP server, I'm able to update Samantha's information right from the app using the MCP server and DApp. So end to end, I was able to use the latest and greatest features from developer tooling, the VS Code MS SQL latest extension, data API builder, JSON data type, JSON index, regular expression, the REST integration calling in OpenAI, the new vector type, diskNN, functions, vector search, which is based on diskNN, and MCP over DApp. This slide actually makes me very happy because everything listed over there is the work that the team has been working on in the past 18 months or 2 years, or in some cases more than that. And it kind of brings the end-to-end story for you as a developer building the latest agentic AI apps on your data in SQL. So with that, I would like to call back Bob to finish this keynote and talk about SQL Server 2025.
Thanks, Mwazwa. Wow. I think you need a chat agent just to understand what the heck you just all said, right?
It's a lot.
If you think about what we've done so far, we talked about a lot about AI fundamentals. We talk about choosing models, responsible AI, grounded, different developer technologies, and then a deep dive. One of the things I asked Mwazma to do was to talk about the fundamentals, to remember sure it's on the same page, whether it's vectors or RAG, but bring you forward into what we see as the future with agentic AI applications. So remember, our goal in the beginning was you getting ahead of AI technology, and I think we've achieved that. So you may have seen in May, we announced the public preview of SQL Server 2025. Yes, SQL Server is not dead. It's alive and well. And one of the things that we put in the main theme for this is the AI-ready enterprise database concept. It's not a marketing slogan, it's real. Why do we do that? Now, what Mwazma showed you towards the end of that demonstration was the use of T-SQL technology to do what? To generate embeddings by talking to a model, storing in a vector type, doing vector distance type calculation, all using T-SQL. We wanted to make sure that SQL Server itself has that. SQL Server on premises, whether you're going to run it totally on-prem, whether you're going to run it like in Azure, whether you're actually going to connect to AI models to run totally on-prem or connect to Azure. So that's why we have this idea that it's AI ground to cloud. But here's the thing. A lot of people know that SQL Server is a trusted enterprise database brand. So we believe what we've built is enterprise ready. So I thought it'd be cool as we end this a little bit today is to show you the future of doing vector searching looks like in SQL. We have this really interesting problem with SQL Server. It's a great mission for our organization. When we put the name SQL Server 2025, we don't miss the name. So we got to make sure we ship it this year. But did you know we can sometimes accelerate SQL Server out there for you in the public faster than the cloud? Sorry, Melissa, we can go faster than the cloud sometimes.
Yeah.
So what I'm going to show is a little bit of the future of what SQL Server 2025 has today in public preview, but will be coming to Azure SQL and SQL Database and Fabric. So you talked about searching, right? Yep. I want to show something pretty cool. What I'm going to do is I'm going to use some new syntax that SQL 25 has to do some of the same things Mwazma showed you for this AdventureWorks coming to do better searching. And I'm going to do it all in T-SQL. I'm going to make it totally secure because everything I'm going to show you is secured by the SQL Server security model you know and love already. You want to see this?
Yes.
Let's see it. Okay. So what I'm going to do is I'm going to first start with this syntax called create external model. I'm going to declare a model I want to use in Azure OpenAI. But by the way, that model right there, Mwazma, could be a local Olama model. It could be an OpenAI compatible model running on-prem or in the cloud. Any embedding model I choose, we're giving you the choice of the model. But notice the syntax. Instead of using that massive stored procedure for a name I can't pronounce all the time, I'm just going to do it declaratively. So when I do this and I run this statement, which again is secured by you, this will now show up as metadata stored inside the SQL Server database. Well, what do I do with this model definition that I have? Well, look at this way of generating embeddings now. I can create a table with that new vector type, just like you showed, but look at this. I can do an insert select in there and put my embeddings right over the T-SQL function. I can create a new vector index. I can create a stored procedure to take that prompt, generate embedding with that simple T-SQL function, and generate something like this. Show me stuff for extreme sports using Azure OpenAI. But you know what? This is a multi-language model already. So I can do the same thing in Chinese and get back the results in Chinese.
Wow.
And I didn't change any code to do it. Because why? I picked a language model that understands multiple languages. So I showed you a new way that's coming to you as a developer to do everything inside the SQL engine, do vector searching, create a model definition, generate embeddings with a simple T-SQL function, create a vector index on top of that, do a vector search with a prompt and the index, and do it the model of your choice, do it multiple languages, all secured by you with T-SQL. So that's the wave of the future, and you're going to see this show up wherever SQL exists, ground to cloud to fabric.
Quick question for you, Bob. So the external model that you mentioned, it supports all of the different endpoints. Could you explain a little bit more?
Sure. That create model statement that I use, if you saw that syntax there, it's going to support a URL endpoint based on 3 different protocols. Mm-hmm. Azure OpenAI, which is going to exist in Azure iFoundry. So that's like a URL, which, by the way, you can protect with a managed identity.
Yes.
You don't have to use an API token. That can be totally secured, passwordless. Number 2, it supports OpenAI compatible. The studies we showed that we did a lot of investigation on this, I was part of working on the team on this, is we found OpenAI has a compatible protocol that's like Azure OpenAI. It's used not as the OpenAI service, but it's used by a lot of local providers. So like, for example, NVIDIA NIM running as a container, VLLM, Kaiser, even Olama is going to now build a OpenAI compatible endpoint protocol. Now, we chose Olama as the 3rd type because we see it as the most popular open source local platforms. In fact, in a longer version of this demo, Mwazma, I showed doing Olama free on my laptop, right? But I use a Hugging Face model that is not multi-language support. And then I turn around and just change my model definition to Azure OpenAI, and I just regenerate embeddings and I'm ready to go. So I think we're providing everybody in a simple declarative way the ability to choose the model you'd like, that you want to use, but in a very simple way that's just consistent in the T-SQL language itself.
So going back to your slide where you had all the models, a model could be on-prem, it could be in a Kubernetes, it could be on a container, it could be in Azure AI, it could be directly in NVIDIA Cloud.
Wherever you want to host it.
So wherever you want to host it through the Create External Model, you can basically access through these 3 protocols.
Think of this future. You're running SQL Server on-prem now with SQL 2025, and you want everything just to be on-prem. Yep. You can do that. You want SQL Server 2025 to connect to Azure OpenAI or Foundry. You can do that. You want to use Azure SQL and connect to Azure iFoundry. And by the way, I'm just going to do a plug for the Foundry team. They're pretty cool. They support NVIDIA models. They have Hugging Face models. I mean, they've embraced a lot of new models in their catalog. Or I could use SQL Database and Fabric and do the same thing. So we're trying to make sure that the model access you need is going to exist where you live, but give you that flexibility and choice.
That's awesome.
So we talked a lot, but there is still a lot more to do. This team is amazing what it is capable of doing. I see it every day. I set one up here on campus. And if I think about the future of SQL and AI, Mwazma, and I think about things that you see we're showing the audience here, one thing we did not show today that I'm super excited about is Copilot experiences. Aaron Stellato and our team, I was just talking to her the other day, if you think about Copilot experiences as a developer or a SQL professional, imagine Copilot showing up in a really cool way in SSMS, Visual Studio Code, GitHub Copilot, Azure, SQL Database and Fabric. Anywhere SQL exists, we've got a whole new set of Copilot experiences coming. So we didn't talk about that today, but that's one of my favorite ones. Do you have a favorite one on this slide? That's one of your futures?
I think the further MCP and agent experiences, as I see the industry kind of going into this agentic experiences, I'm thinking developers need more and more built-in access to that. Some cool ideas around a new way of doing T-SQL, maybe writing stored procedures in a agentic way.
Building agents inside SQL Server?
Yes.
Are you thinking along those lines? Okay.
We are.
That's pretty cool stuff.
So a lot of work in that space. And then, of course, integrations with existing frameworks that are coming out every other day. There's a new framework. So we are continuously thinking about that. And if you have feedback, if you have one of your favorite frameworks that you want support with SQL data,
your team, you have people on your team that just look at MCP and they just spend all their time on MCP, right?
Yes.
I mean, they're staying ahead of the technology. One of the things we also wanted to leave you a message with in this keynote with this slide is that we care deeply on staying on touch of all this, staying ahead of it itself, because we want to relay that to you. We don't want to sit back and say, oh, SQL has AI built in. We don't care about what's happening, new technologies. But what I see Mwasum's team doing is being smart about it. They're not going to just go talk about MCP in some way that's just some fad out there that somebody changed something. They want to make sure it's practical and it promises this enterprise idea. We want to make sure, because SQL is such a trusted enterprise brand. So as we leave today, here's some great, we'll just leave this slide up here. Here's some great resources for you that you can take a look at. Don't forget the deck, AKMS Bobboard MS. We're open source presenters, so the deck is up there for you to take and download, take a look at everything. It's time for lunch. I'm sure you're ready to have some lunch. We have table topic lunch. We are all going to be there as well. You can see us at the tables. If you run into us, please come and ask what you saw on the keynote. Mwasum, thank you so much today. It was a great time with you. Thank you, everyone, as well. Enjoy the rest of your day.
Thank you.